Okay, welcome back. In this lesson, we're going to look at how to be safe and ethical in your investigations. And safety is really important. We don't want this to happen to you. In 2010, 2 students at Texas Tech University in the States accidentally caused an explosion. They both survived, but one lost 3 fingers and suffered burns. Their supervisor had asked them to make no more than 100 milligrams of a compound, but they made 10 grams of it. And when they crushed it in a mortar and pestle, the whole thing exploded. So don't assume that just because something has been done before that it's safe. When I studied chemistry at university, we used to use our mouths to pipette lead solutions, and we definitely don't want you doing any of that. Okay, so in this lesson, we're going to look at complying with safety and ethical guidelines. We're going to look at safe laboratory practices, occupational health and safety guidelines, and a question, are you planning to be ethical in your investigation? So safe laboratory practices is all part of experimental design. It's no point waiting until you actually go to perform your experiment to consider it. It's an integral part of the planning. So when you're thinking about the materials that you're going to use and the process or the method that you're going to use, you need to be thinking about safety right from the beginning. So we want you to wear safety equipment like safety goggles, not end up with a damaged eye. So it's very likely that you've been following safe laboratory practices since you entered a science lab in Year 7. So we're not asking you to do anything different. Being safe entails quite a lot of common sense, and always think about what could go wrong and then think about what you could do to try and avoid that or reduce the risk. So some examples that you'll be familiar with, wearing safety glasses or goggles, always important in chemistry. So safety goggles are a number 1 priority in chemistry labs to avoid chemical splashes into your eyes or if any glass breaks getting into your eyes. Most of you will be regularly using a lab coat or long sleeves. Gloves, it depends on the experiment if you're handling a corrosive material or not, but long pants, closed-toe shoes are all sensible bits of equipment. You probably already know that you don't enter the chemistry lab without your teacher. You never work alone. You always wear appropriate personal protective equipment, also known as PPE. No eating or drinking in the laboratory. Always wash your hands after handling chemicals. Ensure that everything that you handle has been labelled in some way and that it has the appropriate hazard symbols, and we'll discuss those later in this lesson. Know how to operate the safety equipment, for example, how to use the eye rinse station or if your school has a chemical shower. Always use proper storage containers and never hold chemical containers by their lids, always from underneath. Okay, so all of the chemicals that you'll come across in the laboratory and that you already have been coming across, the teachers have all obtained safety data sheets for these. So SDS stands for safety data sheets. Your school might call them material safety data sheets, which means the same thing. That's just the older name before the law changed. But what they do contain is information about toxicity, hazards, safety, and first aid information. So they're very important. You also always want to check that the safety data sheet has been issued recently. Note here that there's a hazard symbol showing, in this case, that the hydrochloric acid is corrosive, which means that you might wear gloves when you're handling it, or if you don't wear gloves, you make sure that you wash your hands if any spills on your hands. The Globally Harmonised System, or GHS, of classification of labelling of chemicals has some universal hazard codes, and you might see these on trucks that are shipping something like sodium hydroxide in very large containers. You might see a corrosive symbol on a truck. So there's various symbols. The first one is explosive. The second one, as the name suggests, is flammable. Looking similar to flammable, but for gases, is oxidizing agents. Compressed gas, this is a gas cylinder here. Corrosive, that we've talked about, things like acids and bases. Whether something is toxic, so the skull and bones. Harmful has just a warning exclamation. Health hazard shows that it could harm the body, and an environmental hazard that's dangerous, for example, for fish. And in that case, we want to make sure that we dispose of the chemicals properly in safe containers in the laboratory and we don't wash things down the sink. So a hazard is anything that could cause harm. And we think about harm risk all the time when we walk across a road. We just want to be able to consider the hazards that could occur when we conduct an experiment or design an experiment. It's a legal requirement that every demonstration and every practical activity is subject to a risk assessment. And some schools subscribe to a program called Risk Assess. You don't have to use that program, but it's one way of checking that you're complying with the regulations. What a risk assessment does is it is a structured way of going through entering the chemicals and the equipment that you're going to use, talking about the safety measures that you're going to use, such as wearing safety goggles and a lab coat, wearing gloves for corrosive chemicals, and addressing all of those things. And it needs to be signed. So it's signed by you when you're designing your experiment and then be countersigned by your teacher. And your teachers and lab techs have already been doing these risk assessments for you for all the other activities that you've done since you started high school. But before you begin, you need to prepare a formal risk assessment. So it's just a simple system to assess and identify hazards and then address safety measures that can be used to try and reduce those risks or reduce the harm that could come. So Lisa found a method for her investigation, and she saw that it's said to include 1 molar hydrochloric acid. The equipment also listed a hot plate, a 25 ml volumetric pipette, and a 100 ml beaker. And one of the products that was going to be produced is ammonia gas. So the hazard corrosive to eyes, we get this from the safety data sheet. The safety measure has to specifically address the actual hazard. And if the hazard is corrosive to eyes, it needs to be something that will protect the eyes. So, for example, wearing safety glasses. Wearing lab coat is not going to protect your eyes. A hot plate, one of the problems is burns to skin, and that's a matter of just being careful, maybe having a sign to remind you that the hot plate is hot and don't touch the hot plate. With glassware such as the pipette and the beaker, glass breakages can result in cuts to skin, and if glass shattered, if you weren't wearing safety glasses, glass could potentially get in your eye as well. Generally, being careful around handling and sweeping up any broken glass and dispose in a broken glass container, which I'm sure you're already doing. The product that we're making is toxic if inhaled, the ammonia. So if inhalation is a risk, then your school might have a fume cupboard Lisa could do the experiment in so that she was not going to inhale any of the toxic gas. So there's 1 mark for each hazard and 1 mark for each safety measure that addresses each hazard. OH&S stands for Occupational Health and Safety Guidelines, and there are regulations here in Victoria, but also there are national regulations. And in addition to the handling of materials and hazardous substances, working in a school, conducting your experiment in a school means the school would actually have to comply with occupational health and safety standards too. This is the Victorian law, which your school wants to provide a safe workplace for the staff and you being there as a student. The hierarchy of controls shows that it's best to start at the top to eliminate a risk rather than just wearing personal protective equipment, which is important, but it's better to try and avoid risks rather than just doing this. So first elimination, followed by substitution, followed by engineering controls or systems to avoid hazard, changing the way people work, and then finally wearing personal protective equipment. Next, are you planning to be ethical in your investigation? So we need to consider if our investigation would have an impact on other people or on any animals. And fortunately, in chemistry, we're not dealing with animals, so that's highly unlikely. But we are working in a lab where there are other students and teachers. And ethical issues can be characterised too as belonging to an internal domain or an external domain. Internal domain relates to the actual experiment, so what you're conducting, and the external domain is the wider impact on society. So some of the considerations for the internal domain: conducting experiments safely, making sure that you don't plagiarize, and we'll talk more about that when we look at referencing. Don't falsify the data, be honest with it. Acknowledge previous research when we cite credible work, and we'll look at that when we look at referencing. And if animal or human testing is permitted, that's undergone an ethics approval through a committee, which doesn't normally happen in the case of chem experiments. The external domain are when new substances are being developed, the effect on environments and the effect on society. Okay, so in summary, you need to conduct a risk assessment. You need to find an appropriate safety measure for every identified hazard. You need to report your results and conduct your investigation ethically. You need to record everything in your logbook. If you record everything, whether or not you use it or not later, it's important to have a record of that. And your school might require that as part of your SAC requirements. Okay, so what's coming next? We're going to look at generating, collecting, and recording data. See you soon. Bye.